Hello everybody, welcome to my new video. Right before I recording this video, I realized that this question probably similar to one of my previous video, but we still proceed with this one since everything is ready. There are more than one solution that I know of. This video we will solve it without using trigonometry substitutions. First is to rewrite Q become Q with index n. In the right hand side, it is almost the same as the original Q, but we replace the 10 with n. Here, n is a positive integer number. If we rewrite Qn become integral 0 to infinity, u multiply dv over dx, and then multiply dx. Of course, some people prefer to cancel the dx. In this format, we can solve it using integration by parts, where u is equals to 1 over x plus 1 and then power n, and then du over dx equals to negative 2nx divided by x squared plus 1 and then power n plus 1. Meanwhile, we define dv over dx equals to 1, so therefore v is equals to x. From here, we can rewrite Qn become uv for x equals to 0 and infinity, and then minus integral 0 to infinity v multiply du over dx and then dx. Of course, some say dx shall be just cancelled, which is equals to x divided by x squared plus 1 and then power n for x equals to 0 and infinity, minus integral 0 to infinity negative 2nx squared divided by x squared plus 1 and then power with n plus 1 dx. Here we can simplify the negative become just positive. Assume the part 1 equals to L, which is equals to L infinity minus L0, where L infinity equals to limits x tends to infinity for x divided by x squared plus 1 power n, which is equals to infinity divided by infinity. We can apply L'Hopital rules become limits n goes to infinity 1 divided by 2nx multiply x squared plus 1 power n minus 1, which is equals to 1 over infinity, which is of course equals to 0. L0 is much simple, which is equal to 0 divided by 0 squared plus 1 power n, which is again 0. So now we know L is equal to 0, which means Qn is solely depending on the part 2. Qn is equals to 2n integral 0 to infinity x squared divided by x squared plus 1 and then power n plus 1 dx. For the numerator, we purposely add the 1 and then minus 1. This step helps us to split the Qn become 2 parts, which is equals to 2n, and then multiply the part number 1, which is integral 0 to infinity 1 over x squared plus 1 and then power n dx, minus integral 0 to infinity 1 divided by x squared plus 1 power n plus 1 dx. Compared to the Qn that we defined at the beginning of this video, we can easily convert Qn become 2n and then multiply Qn minus Qn plus 1. Rearrange it, we will obtain Qn plus 1 equals to 2n minus 1 divided by 2n and then multiplying Qn. We will need this equation later. For now, recall the Qn that we defined. In the case that n is equals to 1, the Q1 is pretty standard. We get the inverse tangent of x for x equals to 0 and infinity. Put in the value of x, we obtain inverse tangent infinity, which is equals to pi over 2 minus inverse tangent 0, which is 0. So we have Q1 equals to pi over 2. Go back to the Qn plus 1. In the case that n equals to 9, we have the Q10, which is the original questions, which is equals to 17 over 18 and then multiply Q9. We can expand Q9 using the same equation, therefore Q10 becomes 17 over 18 multiply 15 over 16 and then multiply Q8. Keep expanding, we have Q10 equals to 17 multiply 15 multiply 13 and so on until 1. Divide by 18 multiply 16 multiply 14 and so on until multiply 2. Finally multiply Q1. And we know Q1 is equals to pi over 2. That brings us to the conclusion of this video. The final answer of this question is 12155 pi divided by 131072, which is approximately to 0.2913. Thank you very much for watching this video until the end. Please continue to support my channel, subscribe, give a like and share my video in your social media. See you soon for next video. Bye bye.